Hello learners, I welcome you all to this particular video session. This session is for senior secondary students who have enrolled in computer science. I am Mohini Arora, HOD Computer Science, and I am here to discuss with you computer software. Computer software. You must all have been very familiar with this term software. A software is a set of programs. In this particular session, we will be discussing about various types of software. We will be discussing about various levels or generations of computer languages, explaining the concept of software, distinguishing between system software and application software, and we will also know the function of language translators. We have two language translators, compilers and interpreters. We will be discussing about them, and we will be defining operating system and its types and functions. So, first and foremost, we start with computer language. We all communicate through languages. If I want to tell you something, it's important that we know each other's language. You should understand what I am saying and I should understand what you say. Similar logic goes with a computer also. Whatever I want to instruct to my computer, the computer should understand and vice versa. So, the language in which programs are written are called programming languages. These programs are a set of instructions that helps us to tell the computer what I want to do. So, these languages can be classified into following categories. We can have machine language, assembly language and high level language. Let us start with machine language. When computers came into existence, everything that was instructed to the computer was through machine language. It is the lowest level of programming language. An instruction in machine language was represented as zeros and ones. That is why this language was also known as machine language or binary language. It was very tedious and time consuming because for every instruction, the code which was consisting of zeros and ones had to be given to the computer. It was hardware specific, and that is why all the hardware and technical operations of the computer must be known to the programmer. These languages were machine dependent. That means the instruction given in a particular machine could not be replicated to other machine. The programs written in a machine language for one computer model will not in at all likelihood run on a computer of a different model. This is what is machine dependent. So, all machine languages were machine dependent languages. The advantages, of course, the execution was fast because I was giving the instructions directly in the binary language that the computer could understand. So, it was very fast, but the disadvantage was that there was no one standard machine language. It was different from machine to machine because it was machine dependent. So, that was the biggest disadvantage of machine language, other than of course, it was difficult to give instructions in the codes of zeros and ones. Next step, we moved on to assembly language. To ease out the programming difficulties that were faced in the machine language, we developed assembly language with some standardized codes. We had symbolics called mnemonics for each and every instruction that could be given. For example, small abbreviations like add, store were used, which were easy to learn, which were easy to memorize and give instructions to the computer. So, it made programming a bit easier. But then this particular assembly language code, which is a source program, had to be converted into machine code, because finally my computer understands only the machine language, only the binary language that is of zeros and ones. So, the source program which was written in assembly language had to be converted into machine code. We call it the object program, and the software that was used to do such conversion was known as assembler. So, assembly language could be used only with the assembler, nothing without that. Next, we move on to the advantages of assembly language. Obviously, they were standardized, the instructions could be given efficiently, they were more easier to use, but the disadvantages, they were usually long, difficult to debug, took a little bit more time than machine language because obviously the conversion by the assembler had to be done. And again, it was also more or less a machine dependent language, means the standardized code could not generally be used on two different machines. Next step in languages was the high level language, much more closer to the English language. It helped programmers by reducing further the number of operations, details that had to be given, the type of instructions that had to be given. We could only concentrate more on the logic of the program to solve a particular problem, and we could give the instructions in a much simpler manner. So, that was what the high level language. Various types of high level languages are available. We have procedural oriented language, which is also known as a third generation language. We have problem oriented language or a fourth generation language. And finally, we have the natural or fifth generation language. Let us concentrate on these various types of languages. But before that, just see the various languages. In machine language, all these are instructions. In machine language, the instruction is given in zeros and ones, you can see that. Assembly language, a small code pack and then the address where the data had to be stored is given. And in high level language, simply we gave the command to print, which I know printing means to write it, to reproduce. So, it is much easier to learn the word print than to learn the assembly language symbols or obviously the machine language. So, you can very well compare the three languages through this particular example. Now, we move on to various types of high level languages. We have procedural oriented languages. These are general purpose programming languages or third generation languages. These are designed to express the logic, the procedure of a particular problem. And because of their flexibility, these languages are able to solve a variety of problems. These require you to instruct the computer in step-by-step fashion what has to be done. Say for example, you want to add two numbers. So, you have to give step-by-step instructions, okay, first input first number, input second number, add the two numbers, print the result. So, these are the 4 steps which you need to instruct to the computer for a procedural language. And examples of procedural languages are Pascal, BASIC, COBOL and Fortran. Advantages of procedural languages over machine and assembly languages are these program statements resemble English language and hence obviously are very easy to work with. Because of their English-like nature, less time is required in developing a program for a particular problem. Then the programs are easier to understand and modify, and obviously they are machine independent. When I am making a program in high level language, I can run it on any system. It is not machine dependent at all. That is the biggest advantage of a high level language. Disadvantage, the programs are executed slowly because these programs which are written in high level language have to be converted to machine language. Obviously, their execution becomes slow and they use the computer resources less efficiently. So, these are the two disadvantages. Next, we move on to the other type of high level language, which is the problem oriented language. This is also known as a 4th generation language. These are designed to solve specific problems or to develop specific applications by enabling you to describe what you want. You may not give step-by-step procedure for getting the result. You may just tell that I want this particular result and the result will be delivered to you. So, the focus is on the output, on the problem that needs to be solved. Focus is not on the procedure that will solve your problem, the steps or the instructions that will solve your problem, and they can be categorized into several kinds. You have a personal computer application software, you have query languages, you have report generators, you have decision support systems, financial planning languages, application generators. These are various problem-oriented languages. As per your requirement, you can choose a particular language, you can choose a particular application in fact, and get the results whatever you want. Let's have a quick look at these problem-oriented languages. Like for example, the first one that we were talking about was personal computer application softwares. These are used for specific applications such as you want to create a document, you want to create a presentation. For creating a document, you have word processors. For creating a presentation, you have PowerPoint. For creating a spreadsheet, you have Excel. All these are different types of applications that you would like to work on a day-to-day basis. So these are the application software. Then you have query languages. Your data is stored in a particular database. You want to retrieve a particular set of data. Say for example, in my file where I was storing the results, I want to retrieve the names of the students who have scored more than 75. So in such a situation, query language comes to my rescue. It allows the people who are not programmers to search the database using certain selection commands. I just give the command that I want this particular set of data through a query language and I will receive the desired results. So this is about query language. Then you have report generators. You have entered the entire data of your class. You want to generate a report. Now this report need not be always a report card. Say for example, I want to generate a balance sheet, taking into account the entire salary of a particular employee or the entire income and expenditure of a particular organization. We have various report generator softwares, we have various report generator applications which are designed for people needing to prepare reports easily and quickly. So examples of query languages include your QBE, your SQL, your RPG, all these are the report generators and query languages. Next we have decision support systems and financial planning languages. If we talk about decision support systems, it is an interactive software. It helps you to decide what decisions should be taken by giving you various criterias, various output options based on the criterias that you choose, so that you can take decisions as per your requirement. Then we move on to financial planning languages. Various scenarios are taken into account so that you can, based on the decisions, you can use the mathematical, statistical and forecasting modeling to plan your finances, to plan your future, your organization's various investment plans can be decided using these particular languages. This is about decision support systems and financial planning. Next you have application generators. This is a software system with number of program modules pre-programmed for various functions. You can decide what function you want for a particular application and the system on its own will select the module and run the program for you so that you achieve whatever results you want through this particular generator. So having talked about the problem-oriented languages or the fourth generation languages, we now move on to the next step, that is natural languages. These are the fifth generation languages. They are still in developmental stages, but yes, our future lies in these languages. These are being particularly explored in the areas of artificial intelligence and export systems. They are aimed at making computer behave more like humans. You must have heard about a biggest disadvantage of a computer, that it cannot make decisions. So now through these set of languages, we are trying to allow the computer to become smarter so that it can actually simulate the learning process by remembering and improving upon earlier information, taking decisions so that human intervention is minimum and the computers can work on their own. Your robotics are a step in this direction. And the popular natural languages are Lisp and Prolog. As I told you before, that high level languages have to be converted into machine languages. Obviously, your computer understands only binary language, but I don't understand binary language. So, this software known as language translators, they are used to convert a high level language into a machine language. The code that is written in a high level language, say C, C++, is known as source code, and this particular code, when it is converted to machine language, I call it as an object code. So, the language translators convert the source code to the object code. Let us learn about these language translators one by one. First, we talk about compilers. In this particular language translator, the object code that is converted can be saved and executed either immediately or later. A compiler converts the entire program into machine language in one go. The errors are given at the end along with line numbers, and it can be executed faster and more efficiently once the object code has been obtained. You can run the object code from one system to another. You can see the various examples of compiler based languages like COBOL, C, C++, FORTRAN. All these are compiler based languages where the object code is obtained by converting at one go. Entire program consisting of any number of instructions are converted into the machine language at one go. Then we talk about interpreters. They also perform the same job of converting a high level language to a machine language, but an interpreter converts statement by statement, line by line. So, each program statement is converted into machine code just before the program statement is to be executed. Translation and execution occur immediately. In case of compilers, first the entire translation was being done, then the code was being executed. Here, translation and execution both occur immediately, one after the another, one statement at a time. No object code is stored and there is no compilation. So, that means every time when you are running an interpreter, you have to convert to machine language each time the program is being executed. In case of compiler, only once it was converted, then you can execute any number of time. In case of interpreter, every time you have to execute, you have to convert it. So, there is no storage of object code as such. Easier to develop and test. For example, BASIC is an interpreter based language where the instructions are converted into machine language one by one. So, we come back to our study of software. As discussed before, software is a set of computer programs that cause the hardware to function in the desired manner. Here hardware, when I talk about hardware, I am talking about the computer system and all its peripherals. We will be categorizing software into two basic categories, system software and application software. A system software consists of pre-written programs and documentation supplied by the manufacturer along with the computer. When you buy a computer, it is not just a CPU, a monitor, a keyboard, a mouse. There is a pre-written program which helps you to boot your system. So, that is what is your system software. These programs are held permanently in the machine, they are never erased. The primary objective of this particular software is to enhance the efficiency of hardware and make computers simple to use. The examples of system software include operating system, language translators and utilities. We will be discussing, we have done language translators before, we will be having a short discussion later also, but yes, we will be discussing in detail the most important system software, that is the operating system. So, this is the operating system. It is the most important system software. You all must have heard about the operating system. You must have heard about Windows as a term, DOS as a term, all these are operating system. This is the system software which acts as an interface between the user's programs and the computer's components. It helps in the execution of the programs. It forms an interface between the user and the computer. Types of operating system, you have various types. You have batch processing, you have multi-programming, you have multi-processing, you have real-time operating systems. So, let us have a quick look at various types of operating systems. First and foremost, the batch processing operating system. It was the first operating system that was developed for the second generation computers. It executes the job in serial manner, one after the another from a batch of jobs submitted for execution. Means if you have given 10 instructions to the computer, this particular operating system will execute all the instructions in a serial manner. So the CPU is kept busy only during the processing cycle of a job and remains idle during input and output operations, because your set of instructions includes the input output operations and the processing both. So when CPU is doing some processing, it's busy. When some input output operation is being done, CPU remains idle. This is what is the batch processing system. Multi-programming system, it can as the name says, it can handle multiple jobs simultaneously by overlapping the input, output and processing cycle of various jobs. So the disadvantage of batch processing system, that the CPU was lying idle, is covered up in this type of system, because the jobs are run simultaneously. Whenever the CPU is idle, it takes over the next job, so that input, output and the processing functions go on simultaneously. This is the multi-programming system. Next, we have multi-processing systems. In this type of operating system, multiple CPUs are used to process multiple jobs. And finally, we have the real-time operating systems. In this, we have the interactive nature of the operating system. It has strict time limitations. Receiving and processing data is done quickly, so that the output is produced quickly. To control, to direct or affect the outcome of the ongoing activity. The example of a reservation system is of a real-time operating system, where I am time bound that the particular job has to be done in that particular time frame. I am reserving a ticket, I am cancelling a ticket, it has to be done in that particular time frame. So this is an example of a real-time operating system. Next, we move on to the functions of operating system. As I told you before, it is an interface between the computer and the user. It helps in managing and sharing a computer's resources, may it be storage devices, may it be printers or any other peripheral devices. All these resources are shared with the help of operating systems. It takes care of scheduling multiple jobs for execution. It manages the flow of data and instructions between the input-output units and the main memory. It helps in user identification and authentication. You must have noticed that when you log in into your computer, it asks for the user ID and the password. So the operating system keeps track of the correct user ID and the correct password being logged in order to allow the user to work on your system. So all this thing is taken care of by the operating system. It helps in protection of users' data and programs, and it also provides facility to detect and correct errors in any of the user's program. You give some wrong command, you don't follow the instructions that are being flashed on the screen. So the operating system helps you to manage out the work that is being done on your system. Next, we move on to language translators, which is translating the program written in any high level language to a machine understandable form, to a binary language, because my computer understands only binary language. So we have three language translators: assembler, compiler and interpreter. We have done about compiler and interpreter. So let us have a quick look at the assembler also. We discussed assembly language before. An assembler converts the assembly language program into machine code. We have to convert the instructions into machine language, into binary language of zeros and ones that a computer understands. So an assembler converts the assembly language program into machine code. Both machine language and assembly language programs are machine dependent. Next, we move on to the third type of system software, that is the utility software. This software is used quite often in the development of a program. These programs are normally provided by the manufacturers, but yes, we can get an add-on utility also whenever we want. These are basically used for housekeeping functions of a computer. Even if this particular software is not there, your system works efficiently, but it is always better to have such softwares in your system. We have examples of a backup utility which is used to take backup of your data, a defragmenter utility which is used to efficiently use your storage area because it compiles the unused portions into a single block so that I can store data more efficiently. You also have something called antivirus utility which is used to remove viruses from your computer. So, all these are utility softwares which helps in the better functioning of your system. We move on to the next broad category, that is the application software. This software is used to perform a specific task or process such as accounting, payroll, making results, mailing. All these are various applications that can be used through this particular software. The majority of the application software is written in high level languages. We have three sources of application software: write it yourself, general purpose package and customer software. When we talk about write it yourself, as the name says, this program is written by the user. So, since a user is writing this program, he knows what his requirements are. So, this particular software will be an exact match to the needs of the business. This program can grow with the business because it is exactly tailor-made, exactly made as per the requirements of the user. Next, we move on to the general purpose application packages. These refer to a set of computer programs which have been written to perform specific commonly required tasks. Each program is written in such a way that it is applicable to a large number of users. These are quite cheap as compared to other softwares because obviously these are created taking into account various users, large number of users, large number of customers. So, this is about the general purpose. It is most likely to fulfill all the requirements of the prospective users. Next category, we have the customer software. It refers to the computer programs specifically written to match the exact needs of the user, but then here a programmer is writing the program. When we talked about write it yourself, the user was himself creating the software. In a customer software, the user specifies his requirements to the programmer and the programmer creates this particular type of software. But yes, it is also aimed at fulfilling all the needs of the customer, and it costs much more than general purpose because obviously it is made as per one specific customer only. So, it is quite expensive as compared to the general purpose software. Common application packages, we have word processor which includes obviously mail merge, we have database management systems, we have spreadsheets, we have presentations, we have communications. So, these are common application, and if I talk about it, about the type of application softwares, these are general purpose softwares. A word processor is used by many people to create a document. Similarly, a spreadsheet is used by many people to create a spreadsheet application. So, these are the application packages which are general purpose, which are aimed for use by many people for various uses. These packages are readily available in the market and one can purchase them, install them as per their requirement and start using them. So, this brings us to the end of the session. In this session, we have identified various levels or generations of the languages. We have learned about software and various types of software. We have distinguished between language translators, that is assembler, compiler and interpreter. We have discussed about operating system and its various functions. I hope this session brought an insight to you regarding software, its types, its applications, and you have been actually benefited by this session. Thank you.